Hi, I'm Doug Black. I'm editor-in-chief at Inside HPC. And today at Virtual SC 2020, we're with Bill Wagner. He is CEO of high-performance cluster management software company Bright Computing. Bill, welcome.
Thank you, Doug. Good to be here.
All right. Well, thank you. So we know this week you're announcing version 9.1 of Bright Cluster Manager. But before we get into that, explain, if you would, what Bright Cluster Manager is and the general direction you've been taking the product leading up to this new release.
Sure. So Bright Cluster Manager is software that makes your high-performance Linux clusters easier to build, easier to manage, and more flexible. It automates the processes of building and managing your cluster and creates a fully functioning cluster from bare metal in minutes. It sets up networking, user directories, DNS, security, it provisions and images your servers for you. It sets up monitoring and health checks. It deploys and configures your workload managers and Kubernetes if you're running containers. And it just makes the cluster available to end users much more quickly. Bright also makes the cluster flexible. It allows you to combine different vendor hardware and chip architectures on the same cluster. It allows you to offer your end users bare metal servers alongside virtual machines and containers from the same cluster. And that allows you to host a combination of traditional HPC applications alongside machine learning and analytics applications. And then Bright also makes your cluster extensible. It allows you to extend an on-premise cluster to public clouds, creating a seamless hybrid cloud infrastructure. It allows you to extend your on-premise cluster to edge locations, allowing you to set up and manage edge compute in remote locations as an integral part of your cluster environment. And it's all about automation. I think in terms of general product direction that we've been taking with Bright, over the last 24 months or so, we've been building towards what we refer to as the new era of HPC. If you think about traditional HPC, it's very much about MPI-based modeling and simulation jobs that are running primarily on Intel-based servers, on bare metal, and running on-premise. I think that's kind of the traditional profile for HPC. But if you look at what's been happening and what's happening more going forward, is what we call the new era of HPC. And in that you have your traditional HPC jobs, as I just described, but you're also bringing machine learning and analytics workloads, into the fold and onto these HPC systems that organizations have. It's not just Intel anymore. You've got AMD and ARM and NVIDIA and GraphCore processors and accelerators. You've got a combination of bare metal and increasingly organizations wanting to use VMs and containers, especially for machine learning and analytics applications. And obviously, while most of the stuff continues to be on-premise, there's a strong desire to leverage the cloud as well and to integrate with the public cloud, and then the edge will follow after that. So to support this new era of HPC that's emerging, we've been very much focused not just on making it possible to do all these things, but to make it easy to do, and specifically focusing on making it easy and more effective for organizations to combine and dynamically share resources across HPC and machine learning workloads, to combine different processors and architectures and allowing you to designate which jobs can use them, making it easy to understand how users are consuming those resources and if they're using them effectively. And we've also been focusing on optimizing data movement between on-premise and public cloud for jobs that are going to run in a hybrid model. So I think we all understand that HPC infrastructure has always been complex, but when you look at everything that's happening in the new era of HPC, as I described it, and the things that are coming into the fold, all of this is going to take complexity to an entirely new level. And so the direction that we've been taking with the product is to eliminate that complexity.
Okay, so I was going to ask you how 9.1 continues the product direction you're describing. Is there anything else you'd like to add?
Yeah, so in 9.1, we've been adding a lot of new capabilities to support everything that I just described. So I'll talk about the ones that we're most excited about. So we've made it possible to spin up clusters as a service in a vSphere environment. And this allows organizations that are using vSphere to tap into unused capacity that they may have to quickly spin up clusters for end users. You can launch those clusters through the Bright interface, which means that your cluster administrators don't need to have any knowledge of vSphere to do this. And you can imagine that organizations can save money by using their vSphere environment to offer ad hoc clusters rather than having to go out to the public cloud. We've also made it possible to run Jupyter notebooks on a cluster, so rather than a single server. And this increases the scope of work that can be performed through a Jupyter notebook. The reason that this is significant is because Jupyter notebooks were designed to run on a single server, and the nature of work being performed by data scientists in machine learning, for example, can quickly outgrow what a single server is capable of. And we've also created an integration between Jupyter and HPC workload managers within Bright that allows your HPC users to work in Jupyter notebooks and submit jobs to the workload manager through the Jupyter interface. We've also introduced Ansible Playbook for building Bright clusters. And this is important for organizations that have standardized on Ansible as their configuration management tool. We've enhanced our auto-scaling capabilities that allow clusters to automatically scale out or change resource allocations for workloads and provides more granular control and better ease of use. And then the last thing that we're pretty excited about is we've also taken a big step forward towards exascale systems by making it possible to create dedicated monitoring nodes within the cluster. And this offloads the monitoring function from the head node, which allows a Bright cluster to scale now to over 100,000 nodes. So we've done a lot of work, obviously, in 9.1, but these are the features that we're most excited about.
That's really amazing stuff. You certainly you're not afraid to take on some really complex challenges. Now, I know your integration with third-party platforms. You've done some extensive work there. Tell us about some of the work you've done, with Red Hat and some of the others.
Sure. So let's see. So in 9.1 specifically, I've talked about the vSphere integration and the Ansible playbook, but we've also introduced an integration with OpenShift, and this allows organizations to use Bright Cluster Manager instead of Core OS. And so the advantages there are, first, Bright Cluster Manager is more of an open system, and it allows you to do more. It's more robust, more visibility, more control over the underlying cluster environment below Kubernetes in OpenShift. And we've also added support for Redfish BIOS management, and this allows organizations that are using products based on Redfish to manage the BIOS across all the nodes in their cluster. So those are the most immediate things that we've done in 9.1.
Okay, great. So looking ahead, what's next for Bright? What are you considering? What should we possibly be looking for in the next release?
That's a good question. So, we see, I think, a tidal wave of change coming in this industry, like I said, and I think we've done a good job of building out the capabilities that organizations are going to need to weather these changes. But going forward, specifically, the big focus areas that I see for us in the next 12 months, probably leading up to the next release, first and foremost, is going to be more cloud integration work. Support, which means support for additional cloud environments, deeper integrations, more automation. And the reason is that although cloud is still a relatively small percentage of spend in the HPC market, it is the fastest growing segment. And based on what our customers are telling us, they're going to want to leverage it more and more. So we're sort of expanding the work that we've already done there, and we're going to do more there. I think we'll be doing more work with Jupyter integration. I think Jupyter is obviously a very popular tool with data scientists for analytics and machine learning, but we think that there's a lot of potential and value for HPC users with Jupyter as well. So we'll be bringing more capabilities out in that area. And then finally, I think automation that spans edge to core to cloud is going to be important. I think as IoT and 5G applications become more pervasive, I think that the reality of edge to core to cloud really being a workflow and a data flow between these tiers is going to surface as the target. And that requires new levels of automation that are going to become clear. And we have some ideas on how to do that. So again, this is all part, I think, of the evolution from traditional HPC to the new era of HPC. And we're very much developing the software along the lines to automate that and make it easy for organizations to do it.
Okay, Bill, really interesting stuff. Thanks for the update, and best of luck, Bright Computing, at this week's conference.
Thank you, Doug.
Thanks.